All right, so today we are going to do electrolytes. This will be a pretty short one. It's not too terrible to cover quickly. I have only 4 slides to cover. And then the assignment, make sure you guys look at it. It's not the 6.3 in the Flexbook. It's a modified version of 6.3 because we're not doing the whole section of what that Flexbook covers in it. So make sure you look for the attached document for 6.3 with the electrolyte lesson plan part in Google Classroom. But let's move and talk about electrolytes. So just as review, let's remember we talked about solutions and we talked about when we have like a homogeneous mixture of a solution. Remember, homogeneous meant that you had it was evenly mixed. Remember, right? Not equal, but evenly mixed. You couldn't detect any certain distinction of different layers. Remember, that was the biggest thing. If you can always see layers, it's a heterogeneous mixture. If you can't tell where things end and where things start, it's always going to be a homogeneous mixture. And remember, we have the solvent, which is the substance we have more of in that homogeneous mixture, and the solute, which is the substance we have less of. Excuse me. And then we also have aqueous solutions. We talked about aqueous things a while back in a couple chapters ago. Which remember we talk about anything that's aqueous. So like if talk about, let's say, if I say NaCl as an aqueous state, remember, that means it's in water. Okay, so water is the solvent now. So now you know a little bit more about why we call things aqueous. So when we talk about electrolytes, you've heard electrolytes before. You've mostly from like drinks like Gatorade, Powerade, all those things. Okay. But what an electrolyte actually is an ionic compound that's been dissolved in a polar solvent. For example, NaCl. NaCl is an ionic compound. Remember, ionic was a nonmetal and a metal bonded together in a polar solvent. Remember, that's the important part. It has to be polar. So NaCl dissolved in water creates an electrolyte solution. Because remember, if we put NaCl in water, okay, what happens is it breaks up into its ions, Na plus in an aqueous solution, so this is in water, plus Cl minus in an aqueous solution. So this is why you don't see the solid sodium chloride anymore, because when you put it in that polar solvent, water, it breaks up into its ions. And this goes for anything that's ionic. And the cool thing about electrolytes is that these ions, these two, are able to conduct electricity. Okay, not a really great amount, so don't go out and buy Gatorade and try and test to conduct electricity through it, right? It'll conduct some electricity, but not enough for you to actually like really observe it unless you have like a voltmeter or something like that. But if any solution conducts electricity, it must contain ions, okay? And that's just for solutions. That's the biggest part. That's not for everything, okay? But if a solution has to conduct electricity, it must contain ions like this, okay? And what also works out is the more ions in a solution, the better the conductor it is. So for example, here we have 2 ions from sodium chloride, right? But if we look at a different type of ionic compound when it's dissolved in water, let's say we look at magnesium chloride, MgCl2, when it's dissolved in water, you get 1 Mg plus ion in aqueous plus 2 Cl minuses. Remember, because it be balanced. This one has 3 ions in solution, which makes this the better conductor then. Okay, that's the important part, is that if you have more ions in a solution that's been dissolved, the better conductor it is. And you can find that out by just counting up the number of ions you'd have. NaCl has only 2, MgCl has 3. So this would be the better conductor. The same goes for concentration, like when we talked about in the last lesson. Concentration is the amount of solute per solution, basically. What I mean by that is if I have, let's say, a 1 molar solution of NaCl and a 2 molar solution of NaCl, the one that has a higher molarity will better conduct electricity. Better conductor. because it has more basically NaCl particles in the solution compared to a 1 molar sodium chloride solution. Okay, so the more ions it separates into, the better conductor. The higher the molarity of the same thing or the same amount of ions will be the better conductor. Okay, so there's two ways you can tell whether things are better conductor. So if we talk about electrolyte solutions, we got to talk about non-electrolytes, which if electrolytes are ionics, basically non-electrolytes are most molecular compounds that do not dissociate in water. For example, like sugar and methanol, okay? So anything that's a molecular, which remember was non-metals, okay, that don't dissociate in water are non-electrolytes, okay? So like you have like your sugar, your alcohols, anything that is basically not a metal and a non-metal. Okay? Pretty simple as that. And then we also, I'm going to talk about this a little bit too. We're not going to go into this a lot because we haven't talked about acids and bases yet. But you can also have strong and weak electrolytes with acids and bases. So like for example, weak acids, okay, like a good example of a weak acid is acetic acid, which you guys have seen a lot of. Which is C2H4O2, or remember CHCOO. Oh, not something else. That's not it. It's the bottom one only. I don't know what I was thinking of. But okay, when we look at acetic acid, okay, oh no, CH3, that's what I was thinking. Why did I mess that up almost? That kind of day today, guys. CH3COOH. Okay. This doesn't actually fully dissociate when it's put into water. So acids actually dissociate a little bit depending upon the strength of it in water. So this actually partially dissociates. Like some of it dissociates and some of it doesn't. So some of it breaks off, some of it stays acetic acid, which makes it a little bit of an electrolyte because you still produce ions. While strong acids like HCl, okay, do fully dissociate into its H plus Cl minus. But if I wanted to draw acetic acid dissociating, okay, I wouldn't put a straight arrow. What would happen is I put an equilibrium arrow, which is a back and forth arrow that shows that the equation happens both ways. So that means I have at any point in time these two ions in the solution and this whole thing in solution, which makes it weak because it's not fully dissociating like HCl. That's pretty much it. Okay, that's electrolytes in a nutshell, really, for you guys. Again, don't forget to check the modified 6.3 worksheet attached, and don't do the one in the flex book. But other than that, we have only, I think, one or two more lessons for this chapter, and then this one's done, and we got one short, quick chapter, and we're on the home stretch, guys. So let me know if you need anything.